I think we are live. Mhm. This is an odd timing for me, to be honest. It's 4 a.m. and I didn't take my sleep at all. Well, I don't know if my OBS is working. Okay, seems like it is. I'll increase. Okay, nice. So we are live. What's the plan? The plan is simple. We are going to do stable partition in the first try. In the first try, we are going to do stable partition, and that is the plan. That is totally the plan. Uh, uh, where are we doing stable partition? Here is the thing I am working on. Hilo lang slash positionless swift. So this is something I am working on currently, and yeah, uh, there are multiple things I am working on. Uh, One is my RSS tier project, that that I want to be part of a Russian standard library someday. But for now, this is the future of generic programming, positionless design in Swift. So let's see. Hmm. Okay. I want to implement stable partition. Let's see how much did I do. I don't know if I can just commit the hook. Yeah, and preserving the relative ordering of only thing. So how it goes like? I don't know. Doesn't seem that nice to me. Let me commit that. Fix stock for partition algorithm, right? And now it's time. I'd be doing stable partition algorithm. And what is the way to go? My way to go is quite simple. Right, I am gonna have a partitioning, and I'm gonna make it to the partitioning of 4 things like this, and stable partition these two, stable partition these two, and then rotate. That's it. Okay, I think for collection I need to have more projections, right? So mutating function with parts from I int comma to j, and we want to pass it to a subsequence dot parts, and it returns R and we return R, right? So this is what we do. Returns the result of passing to F the projection of cell containing parts containing all parts in from to 2, right? And precondition, I think can we have count? Wow, in the with parts count. Nice. Precondition I is less than j for the time being, and I is greater or equal to 0, and I is less than partition count, and same goes for j, right? I don't know. Returns the result of passing F to a partition of self whose all parts except the last part. So there is a concept of last part, right? And when there is a concept of last part, I don't know. What I can do is I can enforce I can enforce the condition on j by including from is less than equal to 2, and from and here 2 2, right? So now it makes sense. Other thing is we adopt the post condition self the boundaries of projected partitioning. Okay. Because yeah, so self adopt the boundaries of projected partitioning, and if the boundaries changes, we also adopt that, right? So this is with parts, and I think there is a one-to-one mapping in the mutable collection also, where we have uh, the mutable projection of self containing all parts, right? And with mutable parts, right? Wow. I can try turning on screen key, right? Uh, Now I know the slice partitioning would have a problem because now we do not have uh, with parts, right? Hmm. So how do we do that? Let me go to collection with parts. Y, and let's try to implement that. So uh, hmm. So what is that? Hmm. Where partition is nothing but slice partitioning of storage and partition start indexes. So let's see what is partition start indexes, right? So this is start index of every partition and end index. So if uh, let me try to draw this whole thing, right? uh, so this was the case. Let's how what it would contain is 0, 3, 5, and let's say 9, and here let's say 7, right? And now I want to get these two, right? So for getting these two, so this is 0, 1, 2, 3, and so from would be 1 and 2 would be 2, right? So what I should have is partition start indexes of 1 to partition start indexes of 3. So 1, 2, 3. This is what we want. 1, 2, 3. So we want to copy that much, right? Hmm. That makes sense. Let me do that. So from and to, what's the problem? It's not in scope, and I think I would just make it an array, and that's it, right? So this is the partition we have. Once we have our partition, we are like, okay, fine. uh, Result is basically uh, the oh wait, the spelling of partition was wrong. So result is basically calling f with partitioning, and right? So what we were doing, so what we need to copy is the position of this index, the position of this index, and the position of this index. Usually this index and this index is not going to change, right? But I do not want to get into the stride and all things, so currently I would just copy all of it, right? This one, and this one. Make sense? The good thing is now, based on slices, what we can do is we cannot just rely on slices, and we can, work with unsafe slices, and that is our own data structure and unsafe mutable slices for I in uh, from dot 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 2. Okay, what we want to do is we want to write partition start indexes of I is partition dot partition start indexes of I, right? This is what we want to do, and we want to return result. So this is with parts algorithm for us, uh, and yeah, I can just copy the same thing, and here I can just paste it with as with mutable parts algorithm, and this is not subsequence dot parts, it's subsequence dot mutable parts, right? uh, I think in mutable collection I make it mistake with mutable parts and subsequence dot, okay, mutable subsequence dot mutable parts, right? hmm. Mutable subsequence dot mutable part. I don't know if this is somehow allowing subsequence dot mutable parts. That is not there, right? So that's fine. hmm. So with mutable parts, and for writing these algorithms, we are really we have a really easy way. We just to write back elements, right, from partition storage to our current storage, and this is how we do with mutable parts. hmm. Partition start indexes. So let me just see if we are doing the right thing. uh, so we copy everything till this point. hmm. Makes sense for me. I really want to say from +1 to 2, uh, so that we only copy the mid one. Yeah. Anyways, I will see that later. So this is the with medieval parts algorithm. Hmm. Right, and collection.swift. Let me ask ChatGPT for something for documentation. Yeah, for that, uh, I have this with parts algorithm. Do you wanna make the doc crisp for partitioning? Right. Here's crisp. Your project a contiguous subset of partitions from to 2 and passes it to F. After the call, self adopts the boundaries of project partitioning parameter. I think I am fine with this. Returns the result of passing F, the projection of self containing all parts containing parts from to 2. Parts at from to 2. Parts in from to 2. That makes sense, right? Variable collection. I don't think all is making any sense, so yeah. Now slice partitioning. This thing is done, variable collection is done, and collection is done. So we implement with, and before that I want to test Swift test thing so that we are sure that we are compiling. I want to be sure in this one. Come on, we are compiling. Yes, we are. Right. So feed added with parts primitive, right? Now once we have with parts primitive, I can just go back on stable partition algorithm, right? So now we have a stable partition algorithm, and stable partition algorithm for me is going to be self dot. Okay, so how are we going to do this? Okay, I want to be on a break. Break. Okay, no timer. Not 5 minutes. It's basically 80-second timer, right? And yes, let's start. I am back. I'm back. Anyways, hmm, I did not get any audience. That's bad. Hmm. Okay, nice. Um, what do we want? I want stable. Okay, so with mutable parts of count 2 p in and p dot stable partition by predicate, right? And we call f of p. So that is the thing, right? uh, what is the complexity here? The complexity is exactly count predicate application. What is the complexity? uh okay. Exactly, and predicates and log n swaps. Exactly, count predicate application and bigger of count dot log 2 of count swaps, right? I don't know if we have this as a bigger complexity. At most count 2 count log count swaps, right? uh hmm. Now what I want is extension mutable partitioning. Mutating function stable partition, right, by predicate, and again predicates just do this, and this time we do not return anything, right? What is element? It's subsequent dot element. Y6j reorders the collection in place so that all elements matching the predicate are moved to a suffix or reorder are moved into parts 1 and rest into parts 0, pressing the reordering of each part, right? And that's it. Post condition, there's no post condition. There is this precondition, and that is mm, partition count is 2 and part 0 is is empty, right? Self part 0 is empty. Hmm. I think it makes sense now. Wow, f of p, and we need to return this, and we need to return the whole thing. That makes sense. Okay, what's next? And I really like this way of thinking about partition. Like you are given bisection, and now you just do the partitioning like this. Hmm. And I need a mutating function stable partition by predicate, and again subsequence dot element should return bool, right? This time n is basically self part 1 dot count. Hmm. Does that make sense? Why are we doing this is so that I do not have to do the order of n combination of count all the time, right? So exactly n predicate application and log and swaps. Hmm. Where n is self part 1 dot count, right? Now we can start doing stable partition. That is the stable partition we needed, right? Uh, so what's the logic? Let's try this out. So uh, here is my logic. I start like that. I think I have this primitive, right? In the collection I usually have this primitive. I did with parts, mutable parts, so I would go to mutable collection with mutable parts, uh, count this, and returns the result of passing after partition, except the last part is empty. So the last part is empty except the last part. Wow. So whose all all parts except the last part is empty, so that last part has all the elements, and then other parts can grow basically, right? So that's fine. I think it would never be a big problem. So we start with this thing that we had nothing here and n elements here. Now what I would do is I would get h, that is n by 2. Okay, now this part would contain h elements and this part would contain n minus h elements, right? And once this part would contain h elements, what I would do is I would add two more partitions like this, and this partition should go here, or first I need to add partitions. First I would add partitions. So here is the thing, I have collection like this, right? Now I would add two more partition like this and this. Hmm. Now I do I would convert it to something like this one. Now if let's say h is basically n by 2, so I would bring I would move I'd grow this part by n by 2, so it would contain h things, and this would contain, so this would contain n minus h things, and this one, right? And then this one, this one, this one, right? And then we do stable partitioning. Oh, this is just so nice, right? This is just so nice. It works so well. This works so well. So I am thinking about a case. What happens when we only have one element? That means this case, right? So now it depends. It basically depends. Uh, so if there is one element and that element should be in second partition, so if it satisfies the pred, then do not do anything. If that is not the case, then transfer all element to prev, right? Or grow this one, okay? Or just grow 0, and that's it. What happens when we have empty like this? For empty we do nothing, right? So yeah, we are quite done with the brain busting. Now I can write the code. So if n is basically 0, we do simply return. If n is 1, we check if we apply predicate on uh, self part 1 dot first, right? We apply predicate on self part 1 dot first. If predicate satisfies, if predicate does not satisfy, we basically, so here is the thing: if predicate does not satisfy, we grow the part 0, right? So grow part 0 and return. So this is base cases, right? Now we are done with the base cases. Now we need to think about inductive cases, right? So if predicate satisfies, yeah, if predicate satisfies does not satisfy, that means it should be in the part 1, and thus we grow and we return. That's fine. Now once we are done with that, let me come back to our first example, and that is the first example, right? So what we do is we do with additional mutable parts of 2, and this is p in, right? And so now we have this structure, right? So we had we currently have this structure, and now what we do is we have this structure, transfer all to next, p dot transfer all to next from 1, right? Why? Because we had exactly the structure, and now we do this thing. So now we have this structure done. Uh, then we are like, let h is n by 2, right? Now we have h, we grow part 1 by h, so p dot grow part 1 by h, and after we grow part 1 by h, we have this structure, and after that p dot transfer all to next from 2, and now we have this structure, right? Now what we do is we basically do a recursive call. So we're like, okay, p dot uh, mutable p dot with mutable parts from 0 to 1 uh 0 to 1 dot stable partition by predicate count. And what is the count for the first one? The count for the first one is h, right? What's the prompt? Generic parameter r cannot be reduced. Why it cannot be reduced? Where is r at all? I'm not seeing any r, right? Missing argument. Okay, something like this. Self dot. What? Cannot convert value of type self dot subsequence dot element to bool to expected argument type self dot mutable subsequence of element to bool. No problem. Cannot convert self dot subsequence. Okay, anyways, I will try first. So from 2 to 3, what we know, what we do is we do stable partition like this one with mutable parts, with mutable parts. And re- recursive case. Okay. Uh, Now I need to see what's the problem with this one. Is it problematic? Cannot convert to mutable subsequence dot element to bool. But I thought subsequence dot element and mutable subsequence dot element is the same thing, so that should not be the case. Let me go to mutable collection. It's mutable slice. Because in the mutable collection I am like mutable subsequence element is actually element, and if I'm correct in the collection I have stated that subsequence dot element is actually element. So if I'm mathematically correct, both should be the same thing. Why? How much are we deriving from this one? So subsequence is slice and this is a mutable slice. Let me see. Uh, I think I would go to medieval collection, and for having medieval subsequence where uh, what I want is medieval subsequence dot element is basically subsequence dot element, and medieval subsequence dot subsequence is basically subsequence, right? And now it's fine, right? Now it's fine. Hmm. It should work now. Wrapping AST. Yeah, we are done. Okay. So, now we are done with the recursive thing, but we need to do a rotate. So we are done with this part. Now I need to do the rotate thing. Let me create a new thing. So this is what we have achieved, and we do a rotate right here. So p dot with mutable parts from 1 to 2, rotate, right? We do a rotate, and what rotate brings us is now this thing. If I'm right, what happens? What happens with rotate? What happens with rotate? So have you had this thing, and we have made sure that this is the one satisfying the predicate, and then we do a rotate like this, 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 and that should be the case, right? So that is a rotate. Now coming to this rotate implementation, what do I think about this rotate thing? So once I do rotate, uh, I what I basically want is I want to bring back this thing here, and this thing, this thing here, right? Hmm. Makes sense. So we do rotate, and once we do rotate, I'm like p dot transfer alt pref from 1 and p dot shift section from 3 to 1, I guess so. 3 to 1, and that's it. This is all we do with additional medieval parts. And once we are done, what happens is I think this is quite nice, right? So This is a case like x case. This is xe case, and when happens we do it like, and let me do it something like this one, right? Hmm. And this is what happens, and we do it something like this. If the case so here we come like EE, here we go like right, and here we go H elements here and n minus H elements here, and here we have H elements here and n minus H elements here. Stable partition of this H bisection, right? So we do stable partition this bisection, and then we do stable partition of this n minus H bisection, right? Right. And then merge step, merge step, and prefix, suffix, this and this. Okay. Uh. Hmm. So this is what we do. Hmm. This seems good. The algorithm particularly seems good to me, to be honest. And what we do is let n is swap part1 dot count, and we do stable partition by predicate count n, right? And that's it. This is all we have, right? one thing I have seen is I would like to have half stable partition uh, here also, right? In the medieval partitioning, I would like to have half stable partition too. So let me just copy this whole thing. Hmm. Half stable partition by this thing. Oh, I am actually hating the resize key maps. And there is a resize one. It somewhere it does resize, right? Yeah. This is something I'm hating. Hmm. Uh, so subsequence dot element, and what we do? Medieval split first. Um, Searching. Mhm. Grow until predicate. Grow part 0 until predicate, right? And if self part 1 dot is empty, return, right? Hmm. With additional part. Trisection should be P. Yep. Mhm. And that is the half stable partition algorithm. Uh, place so that all elements matching the predicate are moved into parts 1 and rest into parts 0. Preserve in the relative ordering of parts 0 only. Front position. This should be 2. I think the precondition is this one. Partition count is 2 and part 0 is empty. Complexity exactly, and predicate application no more than n swaps, where n is self part 1 dot count. I think it's fun. And now what you do is uh, with medieval parts count 2, return this thing, and what should we do? So with medieval parts count 2, uh, 0 dot half stable partition by predicate. Right? Uh, this seems to be fun. So half stable partition, basically we do have two variants. One variant is the one that just calls half stable partition, and the second one is basically this one. And let me do swift test, and it should work, right? That this is all so fine. Let me see. Additional constraints for medieval collection. Nice. I would take a little break. Okay. Timer. Not 5 minutes. Again, as I told, it should be, let's say, 90 seconds. And yeah, play that. I'm back. Uh, uh, uh. Hmm. I'm hating the music. This is so bad. Oh, what about this music? What about this music, man? Here you go. That's great. Uh, but I think I am on the verge of completing this one, right? What do you guys think?
जो अधिष्ठात्री देवी हैं वो हमारी श्यामाजू श्री राधा रानी है जो ब्रजमंडल 84 कोस में फैला हुआ है जिसमें कि श्री राधा रानी का हृदय स्वरूप हमारा श्रीधाम वृंदावन है तो
Okay, let's
आइए
see how, if we
एक
can.
साथ मिलकर युगल छवि का ध्यान करते हुए और श्री राधा नाम का आश्रय लेकर ब्रजमंडल के प्रमुख स्थानों का नाम लेते हुए श्रीधाम वृंदावन से अपनी यात्रा को प्रारंभ करिए
With stable
और मेरा
partition.
विश्वास है कि इस मानसिक ब्रज यात्रा से आपको वास्तविक ब्रज की यात्रा करने का ही फल मिलेगा।
Okay, I do not think I can do this, right? Or we can. I don't think I can do that. So, anyways, now I just go and write some tests. Nice. I can copy this test suite because that was for half stable partition. I can do the same for stable partition, right? Stable partition and stable partition, right? Hmm. And in the stable partition, we can actually maintain the relative ordering of the both things. So I do not need this condition, and rather I can exactly say that what would be the relative ordering. When first part is empty, and that should be the case here. The case here is it should be empty, right? And the case here is both should be empty. And I think I am done. So partition.swift. This way of reasoning about algorithms is so nice. Now it's time to test if we can actually do something. Like, is it working in the first try? Right? Let me see. I hope it does. Let's see what happens. No! It didn't work in first try. That's bad. Okay, fine. Every try is first try, right? What's that? Expectation failed. Mm-hmm. Start index uh, is okay. This one. Oh, okay. Wait. I know what is happening. I actually called half stable partition. So that technically still I didn't check the stable partition capability. So it's still the first try. Now if I fail, then yeah, I lost. Oh my goodness. I lost and I crashed. Okay, anyways. Let's see. What happened? I think this is because I guess in array, yeah, from I really hate if that is the case. So I know that this from to 2 has some problems with parts, right? And here I didn't do that trick. Let's see. Uh, if this works, then again that's fine. Otherwise, I will see again. Yeah, no, I'm doing it bad. Now let's see what is actually happening. Okay. Hmm. Run test case with current. Sendable. Wow, it actually goes into state pair or something. I do not know if that was the case. That's nice. Array.append. There should be something slash partitioning dot init. So slash partitioning dot init had some problem. It seems okay with parts, and there we do slice partitioning dot init and split first collection dot split first match. Okay, when we do split first and then we call with parts, nice. But I thought I called with mutable parts, right? Okay, partition dot swift with mutable parts. So this seems to be fine. I think I would need to see what I'm doing at slice partitioning, right? So it seems like what I'm creating here is problematic. Now why this is problematic? Partition start indexes from to 2 plus 1. Let us check. Let's check that. Right. So here is what happens. I have a collection, a Swift collection, and I want to convert it to some sort of positionless collection that I am working at. So that is 0, that is 3, that is 5, that is 7, that is 9, and this seems to be 11. This is something I want. So 0, 1, 2, 3, 4. And once we have that, one was so from was basically 1 and 2 was basically 3. Now if I talk about these indexes 0, 1, 2, 3, 4, 5, what are the things we need to copy? We need to copy from F to T plus 1. This is something we need to copy. Hmm. So this is what we are copying, right? I do not know what happened. Mm-mm-mm. Mm-mm. Existential, conference to protocol and context. Seems like normal things. So basically thread 8 crashed and okay, nice. So it called stable partition by, and that called stable partition by, and that called stable partition by count, and we do with additional mutable parts for which it calls slices additional mutable parts, and then we do a stable partition, and then we do with mutable parts. Okay, so with additional mutable parts makes sense, with mutable parts. Okay, and then for that we do so partial apply for closure 2 and closure 1, and then we do stable partition, and then we do it with additional partition. We do that. Okay, wow, is that bad somehow with okay, let me change this much. Okay, let me do this much. Okay,
आइए अब मथुरा जी से आगे चलिए ताल वन में कुमुद वन में दतिया जी में बोराई गांव में
okay, so the problematic part is
करुण गोविंद में गंधेश्वरी देवी
this thing
केसरी गांव में शांतनु
from +1 to 2.
बहुला वन में शकना गांव में तोश गांव में बिहार वन में बसोती गांव में राग ग्राम में माधुरी कुंड पे मयूर गांव में छकना गांव में अड़ीग गांव में भजमन श्री राधे गोपाल भजमन
Partition. Okay, I get the point. I get the point. Where I is 0, where j is 0, j plus equal to 1, and for I comma j in zip.
आइए अब गोवर्धन चलिए गोवर्धन में दान घाटी में मुखार वे
This makes sense. Now it should make sense, right? And yes, we are done. I uh swift behavior if closed range as from greater than 2. If swift range uh, greater than lower bound is greater than upper bound will be empty and it would contain no elements. That's fine. So this is what we want. This is exactly what we want with parts, right? And with mutable parts, right? This is what we wanted. Wow, expectation failed. And we start from 1. Okay, we start from 1 with parts. We also start from 1. And we implemented the stable partition algorithm. This is the stable partition algorithm I was talking about. Feet implemented stable partition algorithm. And we are done, guys. We are quite done. Right. Now I can actually raise a PR. Mm, partition. Implement. Partition algorithms. Uh, uh, I think I should review once, right? Partition dot swift. So let's review the review this thing. Uh, reorders the collection in place so that all elements matching the predicate are moved into the suffix, preserving the relative ordering of only non-matching elements. The resulting partition is then projected and passed to F. To F, right? For resulting partition, we read of partition to exactly count more than count swaps. Reorders collection in place so that all elements matching the predicate are moved into suffix of each part, and the resulting partition is then projected and passed to F with returning its result. I think I should also mention with returning its result, so that with returning its result so that we are explicit about returning results. Right now reorders the collection place so that all elements matching the predicate are moved into part 1 and rest into part 0, preserving the relative order of part 0 only. And here order of only non-matching one. So only precondition is this 2, and the 0th one is empty. Complexity and predicate application no more than n swaps. The same should be here. Count predicate application no more than count swaps. And where n is self part 1 dot count. Right. And here a collection place so that all elements matching the predicate move into part 1 and fresh into part 0, preserving the relative ordering of each part. Precondition is this: predicate application at most and swaps, where n is self part 1 dot count. Right. Swap, and n is basically self part 1 dot count. And here we do the recursive one. I think it looks good to me, so I'd raise the PR. Hmm, what I want to write in PR. I have provided I think it's useful to have ability to call partition algorithms on both collection that projects partitioning and partitioning. Directly. I hope that was not mutating here. Talks for improved talks for partition algorithms. The PR So sync, sync. Where's how we can divide and conquer algorithms with positionless design. The pure demonstrate how we can positionless design. And what is the branch I want to raise it to? I think I want to raise it to implement find if branch. Reviewers, of course. I want to add Dave Abrahams, and yeah, regarding files, I think I'm very happy with half stable partition, and all satisfy algorithm with parts, with medieval parts, and the tests. I think it's a good enough contribution, right? $266 lines of work, and yeah, I am done. I am done. So that was all, guys. That was all I have. Should I do some chatting with uh Chat GPT? So, as promised, here is my stable partition implementation. Let me give that implementation to rest. Now,
आइए अब किशोरी जी के बरसाने से कृष्ण के नंदगांव चले। श्री नंदगांव में
now
नंदीश्वर
you
पर्वत
can try to
नंदीश्वर महादेव
know
नंदीश्वर कुंड पे
what
पावन
you
सरोवर
say.
यशोदा कूप में
No, this is much more like I exactly see where you are going for. Let me break down. So by this work, cursor regarding continues but to cursively you and others executing press merge style and lock and no swaps inside partitions. By section elements are moved to their correct position preserving relative order. After their position as a track, tickets license or only license or disease only fully compatible with independent collections or any other language for your design. What can you do? Simply check and unnecessary question for true. Make it easy for the merge. Discover it for extra allocation with while giving you a place to rotate or merge safely. Shift sections. Complex. I take this a textbook example of a stable in place partition for your partition based partition disappear. Assumptions about the cycle items must because I was trying to force single pass swap approach which festival if you want I can draw that I'm sure. Just really need you want to do that? No. Okay, yeah, I think I am done with what I wanted to do, and that's it. I'm done, and yeah, we are done with stable partition. That's all I had.